Hello everyone! In this lesson, we will learn the speed control of the conveyor belt by the FANUC robot. Let's first learn the analog control settings of the speed governor. As shown in the figure, the main components of a conveyor belt are the belt, motor, synchronous gear, and speed governor. The motor is driven by the governor by inputting analog signals to the governor. The speed of the motor can be indirectly controlled. Next, please answer this question. When the FANUC robot controls the speed of the conveyor belt, which signal do it mainly address? A. Digital input signal. B. Analog output signal. C. Pulse signal. D. Serial communication signal. I will give you 5 seconds to think, and we will show the answer after 5 seconds. The answer to the question is B. Did everyone choose the right answer? Next, let's learn the calibration of the analog output signal of the FANUC robot. Here, the magnitude of the analog signal may be controlled by the output analog AO of the FANUC robot. As shown in the figure, the value of AO4 is 4000. The current rotational speed corresponding to the current number 4000 is 181 rates per minute. So how to convert this analog data 4000 into a rotation speed in rate per minute? After completing this transformation, how does FANUC robot flexibly control the rotation speeds through programmers? I believe that you will be able to answer this question through the study of this lesson. We will divide it into 4 steps. Step 1. Perform analog control setting on the speed governor. Step 2. Calibrate the analog output signal of the robot. Step 3. Background startup setting of the robot program. Step 4. Prepare the conveyor belt controlled program of the conveyor model. First, we learn the step-up step to enable governor analog control. 1. Press and hold the mode button to enter the parameter setting mode. Now, the digital to display C100. 2. Change the digital truth indication value to C123 by pressing the up and down arrows, and click the Enter button after completion. 3. Change the indication value of the digital truth to F06 parameters F06 by pressing the up and down arrows. After completion, click the Enter button to enter the parameter setting. 4. change the value of the FO6 parameter to 3 by precising the up and down arrows, and click the Enter button to save and return after computation. 5. If the parameters are set correctly, the digital chips displays N, which will change to the next parameter FO7. After about 1 second, click the Mode button again to return to the speed display. Next, we continue to learn the calibration of analog output signals. Do you still remember the KL4004 analog output model? The model is unidirectional voltage type, and its voltage output rate is 0 to 10 voltage. Next, please answer this question. What is the resolution of the KL4004 analog output model? A. 8 bits, B. 10 bits, C. 12 bits, D. 16 bits. I will give you 5 seconds to think, and we will show the answers after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Okay, let's keep going. In the actual writing of this equipment, we need to respectively connect the port 4, output 4 of the KL4004 analog output model, as shown in the figure. The wire with tap AV1 and the corresponding ground with tap AV1 to 0 voltage, and FWD port of the governor, so as to realize the rotational speed control of the motor. On the robot side, we see that the allocation of AO4 also corresponds to channel 4. The resolution of the KL4004 models is 12 bytes. That is, the 12th power of 2 is 4096, so the smallest voltage charge is 0.00245 voltage. The KL4004 models is unidirectional, and the value range corresponding to its analog output is 0 to 32,757. That is the 50th power of 2. Since the analog value rate is larger than the resolution, multiply values may correspond to the same out voltage. For example, the analog output value is 16,384, and the corresponding output voltage is 5. On the actual circumference, values between 16,380 and 16,388 may all correspond to 5 output. The industrial robot systems use 16-bit site integrate data to stop analog values. In addition, there is also resolution in the response of external devices to analog portability. As shown in the figure, the current speed the current speed of the governor is 181, and its corresponding analog value range may be 4,000 to 4,100. So it is necessary to set multiply sampling port for a narrow calibration and obtain the best fitting curve by taking the average values. The average value through multiply calculations. Next, we decide an experience to obtain the relationship between the output narrowed value and its corresponding rotational speed. The KL404 narrowed output model theoretically corresponds to the voltage output of 0 to 10 voltage. The lowest speed of the motor is 120 rate per minute, and the high speed is 14,000 rate per minute. Because the motor has a starting voltage in a charge operation, it cannot be started from the lowest speed. So we set the starting experimental speed to 135 rate per minute. According to such characteristic, the following calibration of analog output signals can be designed. Experimental steps. 1. Set the analog output value to 3000 and record the actual rotational speed value. 2. Gradually increase the output value by 3000 each time until 30,000 and record the actual speed value in turn. 3. Calculate the conversion relationship between the narrowed indication values and the rotating speed according to the obtained date. The specific process is as follows. 1. Powered on the governor and check the value of the narrowed output port A04 used by the delivered model. 2. Set the value of A04 to 3000 and record the value displayed by the governor at this time. 3. Increase the output value successively in amplitude of 3000 until 30,000 and record the actual speed value in sequence. The maximum narrowed value is 32,767, so the upper limit is set to 30,000. 4. Observe the date characteristic. When the narrowed value is increased in amplitude of 3000, the rotating speed increased by about 135. This is the equation, and we can get the conversion relationship between the narrowed indication value and the rotating speed as follows. Next, please answer this question. Which of the following steps does not belong to the experimental process of a narrowed output signal calibration? A. Set the starting point of the narrowed output value. B. Gradually increase the output value and record the actual rotation speed. C. Adjust the physical position of the governor. D. Calculate the conversion relationship between a narrowed quantity and rotation speed according to the date. I will give you 5 seconds to think, and we will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Okay, let's keep going. 5. Create a new program, 输送带, and write a program for setting the speed, where R3 is a numerical variable for setting the motor speed. The grid mask should be set to none. To set the 输送带 program to run automatically in the background, you only need to modify the data in the numeracy register R3 to change the data of A04. After the background, running settings of the FANUC robot program take effect. It can automatically run in real time. Setting steps are as follows. 1. Find and select background log in the setting column. 2. Select the position where the background program needs to run in the list, and here, select the first line. 3. Then click the Select button. Find and click the program 输送带 in the pop-up program list. 4. After selecting the program to be run, click the Run button to start the program. The status shows running, indicating that the startup is completed. 5. Set the value of R3 and observe whether the speed displayed value of the governors is consistent with the value of R3. Next, please answer this question. In what type of resistors are numerical variables used to set the speed of the conveyor belt typically stored in FANUC robotics programs? A. String resistor. B. Numerical resistor. C. Position resistor. D. I/O resistor. I will give you 5 seconds to think, and we will show the answers after 5 seconds. The answer to the question is B. Did everyone choose the right answer? Okay, let's keep going. Okay, here we can write the program to control the start, stop, and configuration of conveyor belt model. Let's take a look at the actual operations of the conveyor belt. Alright, in this lesson, we learned how FANUC robot controls the speed of conveyor belt, including governance setting, analog signal calibration, and program control. That's all for this lesson. Thank you for watching.